So we're going to continue using the angle pairs that we learned about yesterday to explore the converses of those theorems that we learned from yesterday. We learned that corresponding angles are congruent if our lines are parallel. And today we're going to take that theorem, or with the corresponding angles, that was a postulate. We're going to take that postulate and we're going to reverse it and talk about the converse of it. The converse of it says if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So it's just the converse of the statement that we had from yesterday. For today, talking about the converses. So these would be used in proofs. If we're trying to prove that lines are parallel, we would use the converses of the theorems from yesterday. If the goal of the proof is to prove angles congruent, then we would want the original theorem or postulate. The shorthand for this is if corresponding angles congruent, then the lines are parallel. The alternate interior converse, pretty similar. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel again. And the shorthand, if alt int angles congruent, then lines are parallel. So there was 4 of them. Here's the other 2. Alternate exterior angles converse. If two lines cut by transversal, so alternate exterior angles are congruent, then the lines are parallel. Again, if alt exterior this time, angles congruent, then lines parallel. And the last one is the same side interior or the consecutive interior angles. They have 2 names. Remember that these are the ones that are supplementary, so their rule is a little bit different. If 2 lines are cut by a transversal so that same side interior angles are supplementary, then the lines are parallel. And where we had put congruent in our shorthand before, we're going to put supplementary there. So if same side interior angles are supplementary, then lines are parallel. So we're going to get into some proofs in just a moment. We have one more. Transitive property of parallel lines. We talked about this the other day in class actually, and it just is showing up again in our notes here. If 2 lines are parallel to the same line, then they are parallel to each other. That is called the transitive property of parallel lines. It looks just like the transitive property. See how the Q's are repeating? Remember I said if we're going to link up the others and take out the middle man, that's the transitive property, but instead of being equals or congruent, in this case it's parallel, parallel, parallel again. So P and R over here, parallel, taking out Q, that the middle man that was shared, parallel line for them both. Here we're going to start looking at some proofs. Notice that these are very short proofs right here, just 2 statements and 2 reasons. Each of these proofs uses the picture from the top of the page, and I put them all on separate slides to kind of separate them so it was clear. It's saying that you're given that A is parallel to B, so I'm going to mark them parallel. That means our transversal is this horizontal line going through there. And it says the next statement is that 1 is congruent to 3. So let's look at 1 and 3. We're wanting to say that those are congruent. And the reason that we're going to give is based on what kind of angle pair they are. Also remember we started with the lines parallel. So our phrase here is going to start with if lines parallel, because that was given to us. That was our starting place. Then, now we have to name the angle pair. These are in corresponding locations above the transversal and to the left of the parallel line, above the transversal to the left of the parallel line. So these are corresponding angles. So we're going to finish the statement, if lines parallel, then corresponding angles congruent, to finish out that proof there, really short one. The second one on the page, again, it starts with A parallel to B. So we have A and B parallel. And in this one, they're saying that 2 is congruent to 7. So finding angle 2 and angle 7, we want to say that those are congruent. Our reason that those would be congruent, again, it's tied to the angle pair that they are. Again, we started with the parallel lines, so we're going to say if lines parallel, then here's where we name the pair of angles. These are both interior because they're between lines A and B. That's why they're on the interior. And they're on alternating sides of the transversal. One is above it and one's below it here. So they are alternate interior angles. Just reviewing from yesterday. And if the lines are parallel, then those will be congruent. The third one here, again, we're starting with the parallel lines, A parallel to B. And that was given, and it says given. They said that 6 and 7 are supplementary. When you see that word supplementary, remember that's the same side interiors or consecutive interiors. Those are the only ones that do that. And if you notice that 6 and 7 right here are same side interiors. I'm not marking them congruent because they're not. They are supplementary. So my reason here is going to be if lines parallel, that's an I, if lines parallel, then same side interior angles supplementary. And then we want to say they're going from supplementary to 180, and that's using the definition of supplementary angles, being that if they're supplementary, they will add to 180. So since this is just using the definition of supplementary, that's what we'll put for our reason. Definition, supplementary angles. So those three used the parallel lines were given to you, and then you went from there. On 4 and 5, they started with the angles. So since we're starting with the angles, those are the converses. So we want to keep in mind when we're using this statement forwards and when we're using it backwards. So here they told us that 6 and 8 are congruent. I always identify what kind of angle pair they are. These would be corresponding angles. They're both to the right and below the transversal, to the right and then below the transversal there. So these are corresponding angles. I'm even going to make a little note out here for myself for later. And we want to say that the lines are parallel, and the lines being A and B. And so if these are corresponding using A and B, then we can say that the lines are parallel. But again, we started with the angles, so our statement has to start with the angle pair, meaning if corresponding angles congruent, because that's where we're beginning. Then we're ending with the lines parallel, so then that's the end of the statement. Then lines parallel. If you write this statement in the wrong order, then it would be wrong, because the difference between the theorem and the converse, that is a big deal, that you get the correct one. On number 5 here, again, we're beginning with the angle pair. The angle pair is 3 and 6. They're telling us that 3 and 6 are congruent. These are alternate interior angles. So if these alternate interior angles are congruent, then we can say that A is parallel to B. Again, remember we're starting with the angle pair, so we need to start the statement with the angle pair. If alternate interior angles congruent, then the lines are parallel. So those are those 5 proofs. All right, I'm going to switch videos to try to keep these short.